Okay, good morning children. Today in this session, we are going to see about the types of combustion. What are the types of combustion? Bring a burning matchstick or a gas lighter near a gas stove in the kitchen. Turn on the knob of the gas stove. What do you observe? Okay, so we are going to take a matchstick or a gas lighter and we are going to turn on the gas stove and we are going to lit it. We find the gas burns rapidly and produces heat and light. Such combustion is known as rapid combustion. Okay, as soon as the gas stove lights, okay, immediately the fire will form. Okay, this is called as rapid combustion. There are substances like phosphorus which burn in air at even room temperature. The type of combustion in which material suddenly bursts into flames without the application of any apparent causes is called as spontaneous combustion. Okay, when we take a lighter near a gas stove and if we open the knob and light it, immediately the gas stove will light up. Okay, but this is called as rapid combustion. Rapid combustion means speedily. Okay, speed combustion and spontaneous combustion. Some chemicals such as phosphorus and all, if it is kept in normal room temperature, sometimes it will cause fire. This is called as spontaneous combustion. Spontaneous combustion of coal dust has resulted in many disastrous fires in coal mines. Okay, in coal mines, sometimes the coal mine will caught fire because of this spontaneous combustion. They don't need any fuel or any matchstick or anything to get fired or get combusted, but it spontaneously, immediately, without any inducing material, it caught fire. This is called as spontaneous combustion. Spontaneous forest fires are sometimes due to the heat of the sun or due to the lightning strike. However, most forest fires are due to the carelessness of human beings. Okay, some forest fires are due to the carelessness of forest fires or caused because of human beings. It is important to remember that the campfires must be completed, extinguished before the leaving a forest after a picnic or a visit. Okay, because of human beings only, most of the time the forests are being caught because some of them they will make campfire and all, and because of that campfire some spark of a light is left behind. Because of that spark the whole forest is caught fire. Okay, we generally have fireworks on festival days. When a cracker is ignited, a sudden reaction takes place with the evolution of heat, light and sound. A large amount of gas formed and the reaction is liberated. Such a reaction is called as explosion. Okay, in Diwali times we used to fire crackers and it will explode with a higher explosion, and that explosion is given here. Explosion can also take place if pressure is applied on the cracker. Because of the pressure applied on the crackers, the explosion is taking flame. So far we have seen what is combustion, and now we are going to see about what is a flame. Okay, so see here, this thing is a flame. This orange thing is a flame. Observe an LPG flame. Can you tell the color of the flame? What is the color of the candle flame? Recall your experience of burning magnesium ribbon in class 7. You have not experience of burning the remaining items. You can do that. Okay, so now we are going to see how a candle forms a flame. Will a candle forms a flame? Definitely candle will form a flame. Okay, will magnesium form a flame? Will camphor form a flame? So we have to go through these experiments and we have to fill this topic. Okay, is it clear? And now we are going to see what is the structure of a flame. When a candle flame is steady, introduce a clean glass plate into the luminous zone of the flame. Hold it there with a pair of tongs about 10 seconds, then remove it. What do you observe? A circular blackish ring is formed on the glass plate. This indicates the deposition of unburnt carbon particles present in the luminous zone of the flame. Okay, if we keep a glass slide near the flame, the flame will form a black color circle. This black color circle is due to the unburnt carbon dioxide molecules. Okay, the substance with vaporized during burning gives flames. For example, kerosene oil and molten wax rise through the wick and are vaporized during burning and form flames. Charcoal on the other hand does not vaporize, so it does not produce a flame. In activity 6.5, put the vapors of wax coming out of the glass tube because of the flame produced. Okay, the substance which vaporized during burning gives flames. Okay, when do we have a flame? the substance which vaporize during burning will form a flame. Okay, is it clear, children? See here, now different zones of candle flame is given here. So there is a yellow color part inside, and around that there is a orange color part, and outer zone of the combustion. See, there is a blue color flame, and hottest part, it is moderately part, the least hot part. Middle zone, have you seen, we have done like this, we can light a candle and we can move our hands inside it. The inner part will not be that much hotter. Okay, so middle zone of the partial combustion, yellow. Innermost zone is unburnt wax vapors. It is black in color, and this is the wax candle. Goldsmith blow the outermost zone of the flame with a metallic blowpipe for melting gold and silver. Why do they use the outermost zone of the flame? Because the outermost zone of the flame is having very hot, the heat we can observe very much is in the outer part only. Okay. What is a fuel? Next we are going to see about what is a fuel. Recall the sources of heat energy for domestic and industrial purposes are mainly wood, charcoal, petrol, kerosene, etc. These substances are called as fuels. A good fuel is one which is readily available, it is cheap, it burns easily in air and at a moderate rate. It produces a large amount of heat, does not leave behind any undesirable substances. A good fuel, which is a good fuel? A good fuel is one which is readily available. Okay, so kerosene, petrol, diesel, these are very easily available fuels and they are called as a good fuel. It should be cheap. It burns easily in air at a moderate rate. It should produces large amount of heat. It does not leave behind any undesirable substances. There is probably no fuel that is considered as an ideal fuel. We should look for a fuel which fulfills most of the requirements of a particular use. If we say petrol or diesel as a good fuel, but it is not that much good because they are very costly. So, a good fuel, an ideal fuel should satisfy all the needs of all the rules of a fuel. Okay, fuels differ in their cost. Some fuels are cheaper than others. Make a list of the fuels familiar to you. Group them as solid, liquids and gaseous fuels. So, fuel efficiency. Next we are going to see is fuel efficiency. Suppose you are asked to boil a given quantity of water using cow dung, coal and LPG fuel. Which fuel would you prefer? Okay, what is a cow dung and what is a coal and what is an LPG fuel? If you are asked to cook in these three things, using these things, which will you like the most? Do these three fuels produce the same amount of heat? The amount of heat energy produced on complete combustion of 1 kg of fuel is called as calorific value. This is a very important question. What is the calorific value? The amount of heat energy produced on complete combustion of 1 kg of fuel is called as calorific value. The calorific value of a fuel is expressed in unit kilojoule per kilogram. Okay, kilojoule per kilogram. So, some of the calorific values are given here. For cow dung, the calorific value is 6,000 to 8,000. For wood, 17,000 to 22,000. For coal, 25,000 to 33,000. Petrol, 45,000. Kerosene, 45,000. Diesel, 45,000. And methane is the having highest. Methane and CNC will be having the highest calorific value, 50,000. And here, hydrogen. 1,50,000, biogas 35,000 to 40,000, and also LPG is having a higher value of 55,000. Okay, burning of fuels lead to harmful products. This increasing in fuel consumption have harmful effects on the environment. Carbon fuel like wood, coal, petroleum release unburnt carbon particles. These fine particles are dangerous. These unburnt carbon particles are very dangerous pollutants causing respiratory diseases such as asthma. Okay, the minute particles of carbons are is polluting our environment and they cause asthma and other respiratory diseases. Incomplete combustion of these fuels give carbon monoxide. It is a very poisonous gas. It is dangerous to burn coal in a closed room. The carbon monoxide gas produced can kill persons sleeping in that room. Okay, so that is why we are advised to never sleep in a room with burning or smoldering a coal fire in it. Okay, so we should have a keen observation whether we are sleeping in a safer place. Combustion of most fuels releases carbon dioxide in the environment. Increasing concentration of carbon dioxide in the air is believed to cause global warming. We all know about global warming, and what is the cause of global warming? Because of these pollutions, mainly carbon monoxide and carbon dioxide. These are the main causes of making the global warm in nature, and it is causing because of the pollutants of our air pollutants. Global warming is the rise in the temperature of atmosphere of the earth. This is among the other things in the melting of polar glaciers, which leads to a rise in the sea level, causing floods in the coastal areas. Low-lying coastal areas may be evenly permanently submerged under water because of this global warming. Because of this global warming, a big ice glaciers are being melted, and it increases the water level, and because of the increase in the water level, the nearby seashore villages and lower areas are being covered with seawater and has been destroyed. All these things are because of the global warming. Burning of coal and diesel releases sulfur dioxide. It is an extremely suffocating and corrosive gas. The most suffocating and extremely suffocating corrosive gas is sulfur dioxide. Moreover, petrol engines give off gaseous oxides of nitrogen, oxides of sulfur and nitrogen dissolve in rainwater, and forms of acids such as acid rain. Okay, oxides of sulfur and nitrogen, okay, the oxides of sulfur and nitrogen are released because of the automobiles, and the sulfur and nitrogen will go to the atmosphere, and there we are having water vapor. This water and sulfur combines together to form sulfuric acid, and nitrogen and oxygen, water vapor combines together to form nitric acid, and these nitric acid and sulfuric acid are contaminated with the clouds, and from there they form as acid rain. Okay, if we have that acid rain, our skin will have cancer, and our skin will be affected, and so many diseases will be we have for because of this acid rain. It is very harmful for crops, buildings and soil. You have already learnt about this in class 7. The use of diesel and petrol as fuels in automobiles is being replaced by compressed natural gas, because CNG produces the harmful products in very small amounts. Okay, instead of petrol, diesel and petrol, diesel, coal, instead of that we have to use CNG, okay, compressed natural gas. That much of poisonous gases are not evolved from this CNG. So it is very useful for using instead of petrol and gases. CNG is a cleaner fuel. Okay, so far we have seen in this lesson about acid rain, calorific value, combustion, deforestation, explosion, flame, fire extinguisher, fuel efficiency, global warming, ideal fuel, ignition temperature, inflammable substances. Is it clear, children? If you have any doubt in this lesson, you can feel free to ask me, and in the end of the session I can give you some questions. Thank you.